And on the third day, let there be water. And as you can see, on this part, of course, we will see how we can create water and change our blocks from the solid state, from the state they are, so we can create dynamically new blocks so that we can simulate water, basically. Okay, now we're not going to mess with the animations Minecraft does. That's only simple change in the mesh data script we wrote in the previous videos. Okay, and on this part we will mainly see how we can take the logic behind creating new blocks of water, or just, of not creating one. So now let's talk a little bit about the logic behind it. Now this the blocks we are instantiating, the new blocks we are creating, they are not infinite. Okay, and by that I mean, if this was a pretty flat area, so let's see it. Okay, if I set my elevation to 0, we will have a pretty much a more flat world, as you see here. And if I put my water somewhere around here, you will see that it will not go on forever. Okay, otherwise it's going to flood our whole world, and we do not want that. Okay, so the logic behind it: we place one block of water. Okay, and then we start looking. The first thing we are going to do is we are going to see what type of block we have below us. If there is a solid block, so it's basically there's ground there and not air, then we can expand placing blocks sideways. If there is not a solid block, that means it's air, then it means that our water will fall down. Okay, and you will see that if it's going to the edges, it's going to keep falling down and keep falling down until it finds a ground, and then it can expand on sideways. Now the only place we are not placing blocks, the only direction we are not going to place blocks is upwards. Otherwise, pretty much it was going to flood the whole area. Okay, and we're also counting from the point of origin, the point of our main block where we set our water. We also check how many blocks we have. We basically check not how many blocks we have placed, but the distance from the main block. But we only check it on sideways, because otherwise, if this had pretty high elevation, okay, if we were counting on how much downwards our water goes, then pretty much our water will have stopped on mid-air, basically. Okay, and as you can see, we're getting pretty good results. Now it's not that optimized right now, but you can, because we are running a lot of stuff on, basically for every block of water we are running stuff on update, and of course it needs a little bit more of optimization, but when I'm not recording I can get 60 FPS, so it's not that bad either. And it drops a little bit. Now that I'm recording, it might drop to, I've seen 30 FPS, but if I'm not recording, then we do not have that much of a problem. Now we will primarily work with the scripts we wrote in the previous videos, in the previous parts, but we are going to create a new block which is going to be called block water. Okay, and create this new script, and then let's open up our block script, which is the basis for all our blocks. Now we need a reference to our world because we're going to get the chunk. We want to be able to get the chunk we currently are. Our block is currently at. Okay, and the coordinates for us to get our block. And then we need a function which is of course going to be public, set world, which basically stores, returns our world, and we also can get the block from there. Then the tick is pretty much the same as update, but if you see on other coding languages, you'll see that they use tick instead of update. Okay, and over here we will use the tick on to store, to run the logic we want on our water blocks. We will use this function, you know, to run it. You will see in a bit later. So public virtual void, keep in mind the keywords. A lot of errors I see and a lot of mistakes you are contacting me about is about this little few words. So after that, we're going to create a new list on our world script, and I forgot about that. Let me open this up. Now we're going to create a new list on our chunk, not world, on our chunk script, which is basically this list. Okay, we're going to store every block we want to run logic on update. We're going to store it inside this list. Okay, pretty simple stuff. And then for every block we have inside that list, we're going to use a for loop, and we're going to run the tick function. Okay, since this block is the main is the upper class, so every other type of block takes from this class, we have to use the tick over here. Okay, even though it's a virtual void, it's virtual so that we can override it on a subclass. Okay, and basically if the block is block grass or something else, or like block air, they're not going to run any logic over here. Okay, so with this function we basically take the block and we add it inside. We take the chunk, we take the block, and we add it inside the list. Okay, and this function will unregister that our block from that list, and that's pretty much what you need to do inside what you need to change inside the block script. Okay, we saw what we need to add on our chunk script. Okay, the list and the for loop. Now keep in mind that this is not optimized. This will run on every frame. So let's go into our block water. We first need to know how far we are from the main water block that we placed inside our world. Okay, the tick interval is how many times the tick is going to actually run. Okay, this in Unity, by default in Unity, the update runs on time delta time. Okay, and if you go into project settings, time, you will see that you have your time scale, your fixed time step, which basically how much time the fixed update is. Okay, well, basically we're creating something like that, a simpler form like that, so that we can run our logic, but we do not want it to run on every frame. Otherwise it will instantiate all our blocks into the same frame, and it will be hard to check for progress. Okay, you will basically see the lower this is, the faster it will create new blocks. Pretty much the internal timer. Okay, so we override the tick from the upper class, from our block upper class. Okay, and of course it needs to pass a delta time. Okay, we add to our timer with our time, and if the timer is higher than our tick interval, we reset, of course, the timer. And then if we have room to place, if we have enough room to place more blocks, so we're not that far away from the main block, then we can continue and place blocks around us. However, if the first thing we're going to check is if we have a block behind us, not behind us, below us. Okay, so if there is a block that is not air, so we're basically sitting, we are sitting on the ground. Okay, and of course if there's not null, so that we are not getting errors. Okay, so if we are not on the air, we will continue and place the blocks sideways. If we are on the air, however, okay, we cannot place any more sideways, otherwise our water will expand on the air, you know. Okay, so what we need to do, well, basically water will fall from by gravity, you know, in real life. So what we need to do is we need to add a new block below us that is, of course, water. Okay, so we set a new block of water below us, and now, because the above function we didn't have a way to get back our block, we need to take it manually. So we create a new block, and we use the previous function we have written, the get block. Okay, and we take it, we cast it as block water. So now we know we have our logic. However, we need to check first that we have a block. Okay, otherwise, because if we are at the end of the grid, then we will be getting errors because there won't be any block to return. So then we take the new block we just added, and we want to pass it into the list so that it will run the logic that checks if there is if it can place water around it. Okay, so that's basically how we create a new water script, a new water block. And then the first thing we are doing is checking what is below us, and if there's ground below us, we start placing stuff around us. Okay, now if instead of the air there is water below us, then we cannot place any more sideways. That means we are placing water upon water. Okay, so it wouldn't happen. There wasn't going to be anything else. Okay, now if you have more blocks like lava or something else, or fire or whatever else Minecraft has, you will also add the logic of what was going to happen over here. Okay, you will simply add more else ifs and stuff like that. So this is if we have a bottom block. Okay, if we can't place blocks sideways, that means we simply need to check for every direction, which is basically forward, back, left and right. Okay, we are not checking up, we checked if we have something below, and you pretty much, since this is a grid, you do not have to check if there is on the corners. You don't have to check diagonally if there is a block or not, because the next one we are going to place to the side is going to look if there is a available space on the forward, if it's in front of him, so it's going to create a new block from that block instead of using our block. So we check on every direction instead of up. If we can get a block, we get the block that is on the direction we place. Here we use the forward block. Okay, if there is a block forward, okay, and it's not in its block air, we create a new water block. We get the new block water. and if there is actually a new block, so we're not getting nothing instead of so basically we're avoiding errors over here. Okay, we set the new block, we add it inside our list of update, in the list of the blocks we're going to update the logic, and then we add to the distance from the main block. Okay, now as I said, we're only taking into account the distance when we are moving sideways. Okay, if we were moving downwards, then our water will have stopped on mid-air. No matter how far the elevation is, our block of water, yes, it's going to fall. It's going to go as low as it gets until, of course, it runs out of distance from the main water block. Now, the same for every direction. Okay, pretty much the same. We're only changing the stuff over here. Okay, so we're basically changing the direction and we're adding to the distance. Okay, this is the back block. Pause the video and write it. The left block, the right block. Basically the direction is not the right block. We're checking if there is a block to the left, to the right, forward or back. Okay, now if we couldn't place any more, or if there wasn't an available position, then it will stop. It will simply wouldn't place anything else. Okay, so this basically is a tick, which is a function that we're going to be calling on update from the list, which is basically why we store our blocks inside the new list we created. Okay, and the texture position, you simply change it to have the texture you want to have. Okay, so the only thing left is, of course, add the logic that we actually have a water block. Okay, so I'm going to change the block click, the way we placed the blocks on our previous video. So when we are clicking, okay, we take the recast, we take the position, we clicked. Now we actually want to take the block above from what we hit right now, so I've deleted the -1. So we check to see if we hit a water block and if we actually take a block of air instead of a water block. Okay, and we added the stuff also because we need to check what type of block we clicked. So if the block we got back is a block air and it's not block water, so we're not placing water above water, then we create the new water block. We get the block we just placed. Okay, as I said, because this function doesn't return our block, we get the water, the block we just placed. Okay, we update the water in the chunk, and then we simply take our block and we add it inside our register for update list. Okay, so we're basically adding this into this chunk, into this list, and then on update it's going to run the whole list and basically run the tick, and we're passing the time delta time, and of course the tick is going to come in here and run all this logic. Okay, simple stuff, pretty basic stuff, somewhat basic stuff. And of course, if you want to create the animations the Minecraft has, let's close this, when you're placing water, like you know, that they're not exactly blocks, but they are, you know, there are a different mesh. You simply have to tweak around with the mesh data and the vertices. So instead of placing them on the same position as the block, you can even animate them, or you can make them you know, have a different mesh. So, and if we change the interval over here, let's place it to 1, you will see that the rate that we're creating new blocks is going to go even slower. So every second it creates new blocks, and you can see over here, you can see that it places basically the logic we have. If it finds a solid ground, it's going to expand sideways. If it doesn't, then it's going to expand below, and so on. Okay, so that's basically it. Now I wasn't planning this week to do this video, but you requested it a lot, and I'm a crowd pleaser, as you know. Okay, so I jumped a little bit on my schedule and created this instead of the previous, instead of the other video I already had planned. Okay, and I actually have a lot of new stuff planned, and we're going to expand on even more and better things. So you just have to sit around and wait. So thanks for watching. Don't forget to like and subscribe. If you like the videos, then consider supporting me on Patreon so that we can create even more cool stuff like this. Okay, and I'll see you next time.